Hello, I'm going to give a quick demo of our physical computing project. It's an omnidirectional robot with 3 stepper motors which connects to my phone via ESP32. So yeah, before we get onto that, I'm going to show you the 60-second video that we made about our project. So I hope you enjoyed that video. We're now going to go into the actual demo. So yeah, you can see we have the robot. So I can actually plug in the logic supply and then plug in the stepper motor supply. And then you can see it's going to blink to indicate that it's switched on and in pairing mode. I can then connect my phone to the robot. So I've started a recording so you can see what I'm doing, and you can see the robot here is moving. I can actually go into the controller and change different things like the rotation. I can go forwards. It's also, because it's omnidirectional, I can go left and right. I can also record a sequence. So I press record, go forward, turn round, go forward, and then I can press stop. I can then go in the sequences menu and click reversed and then play that sequence. And it's actually going to do the whole sequence in reverse. I can also make it do the original sequence, make it go back. So, we've also got the LED strip control, so I can actually make kind of like a light show if I wanted to. So maybe we'll start off red, and then press record, go forward, switch to green, go forward, switch to another colour, and then stop recording. And then I can go back into the main sequences and play that sequence again. So it's starting off red, and then it's going to switch. So yeah, we've also got the status monitor screen, which allows us to see various parameters of the robot. So I'll bring it back just so we can see it again. You can see here we can go into the stepper motor menu, which allows us to control each individual stepper motor. So we can turn this stepper motor on, it's going to spin, turn it off, can turn it on again and switch the direction as well. And then we can also go down to motor 3 and control another motor as well. Yeah, so that's really good for being able to tell whether a motor is working properly. And we've also got the TOF sensor menu. And the robot's going to illuminate 4 different colours for each sensor. And then if I cover a sensor, it will go down. If I cover another sensor, it will go down as well. We've also got some scripts which utilise those sensors. So for example, if I put it in a bit more of an obviously obstructed space, I can press roam, I can press play, and it's going to move forward, and then it's going to realise in a second hopefully that it can't go forward anymore. Great, so it's turning round. And then it's going to go forward and carry on roaming around. There's also follow me, which allows me to use the sensors to tell the robot where to go. So if I put my hand here, it's going to follow me in that direction. And we've also got the radar. So if I place the robot on here, and then I run the script, the robot's going to do 12 ticks to scan the room, which will be 90 degrees. And then we have a profile which we can use of various angles and their distance measurement. which we can then use some trigonometry to plot on a standard XY chart. Here we go. And you can see, so it's seeing a really vast empty space probably over here, and then it's seeing something obstructing it back here, which is good. So you can see here, here's our power bank. It lasts quite a while, so we're currently at 82%, and I think we started at 90%. We've also got the logic power supply. We've got an ESP32, which has Bluetooth and Wi-Fi. We're using Bluetooth Low Energy to communicate with the phone. We've got 4 stepper drivers, so we've got A4988s. We've got a multiplexer as well, which connects to the I2C devices. And we've also got 4 time of flight sensors, which are positioned in this 3D printed package here. They're just screwed in. We've also got a NeoPixel strip going around the edge, which we can control using the phone, and we can control each pixel individually, giving that kind of cool user interface with the sensors. And we've also got a 5-volt buck converter and power distribution circuit, which we've made to power all the different components from the power supplies. And in addition, we've got NEMA 17 motors on the actual robot, so don't want to rotate it, but you can see down there, they're quite big. They're the same thing that you have in a 3D printer. And we've also got Omniwheels, which we just bought from a shop, which have rollers allowing you to move in any direction. So yeah, that's a breakdown of the electronics of the robot. Thank you.